Hi everyone, we're looking at example of a rebate edge concrete slab, and this time we're going to do the concrete component of it. Okay, so we're using the into-over method, which we've discussed in class, and visually I would recommend that you always draw this plan because it's going to help you visualize what you're actually writing down, what your calculation is. Okay, so the slab component, we've got two areas, area 1 and area 2. And there's the area there, and there's the answer for area 1. Then we move to area 2. We break it up into two areas because it's just a simpler way to do the calculation. Then we get the total number of cubic meters. Our depth here we can see is 170 millimeters, and that's just the surface area. They're 11.64 and the 12.56 and the 6.24 and the 8.7 times the depth. Then with our beam component of the slab, we go around and we list all the sides again, starting at the top with A and going clockwise. Then we start to put in the lengths for each side, the plan length, and then we look at any deductions, which there are deductions of 450 mil on everywhere except for C and D, because that's an internal corner, and you can see we lose a little bit there, but we pick it up there. Okay, this is consistent through all our calculations. So there's no deductions. Then we go back to our 450 deduction for E and F, and then we just get the totals. And we get a total of 64 meters of total beam length in the slab component of that rebate edge slab. Then what we do, we calculate the beam section. We've got to calculate this beam section because that's the beam section there, and that's got concrete in it. So we just calculate that area, and then we times it by the length. So our beam section is 0.45 by 0.4. There we have it there. That gives us a total of 0.18 meters squared. Then our triangle, we've got a formula of half the base times the height. And our triangle is 200 millimeter sides, so it's half times 0.2 times 0.2, and that gives us 0.02. Then when we total those sections up, it comes to 0.2. Okay, so then what we do, to get the volume, we times our length, which was 64. We'll just have a look at that. So there's our 64 times our beam section, 0.2, gives us 12.8 cubic meters. Okay, so then we've got to do the rebate edge. So we just list the sides again clockwise. We put their sizes down, and then we deduct the 150 mil because this rebate is 150 mil. And we don't have any deductions on the corners, exactly the same as everywhere else. On our internal corners, there's no deduction in the into-over method. So then we get the totals. Okay, then we get the total number of meters around the outside of this slab. And what we do then, we calculate the volume. And that volume is 65.2 times the width is 150 times our depth is 170. Okay, so that gives a total of 1.663 cubic meters. Okay, so what we've got to do then, we've got to add the slab meters cubed and the beams meters cubed. So our beam meters cubed and our slab meters cubed are, there's our 1.663, beg your pardon, there's our 12.8 cubic meters there, and up above that we've got 42.083 for the slab component. So we go down here, okay, so we've got the slab, we've got the beam, and then we take away the rebate. So there's the rebate there, and that gives us 53.22, and we can't get 53.22, so we've got to go in increments of 0.2, so our concrete order is 53.4. and we just transfer that over into the costing area, and that's it. Okay, so there we have it. All right, thank you and good luck.